Welcome to another deep dive. This time, we're going to take you on a journey through the world of an element I bet you haven't thought about too much lately. Cadmium.
Cadmium.
Yeah, it's fascinating.
We've got a whole stack of sources here.
Wow.
Everything from the Royal Society of Chemistry periodic table and Wikipedia
Right.
to a scientific paper on its history and even a snippet from a chemistry podcast.
Oh, wow.
And trust me, there is so much more to this element than meets the eye.
I believe it.
Did you know that it was once used in medicines,
Wow.
but is also toxic enough to cause a disease with a name you won't soon forget?
Ouch disease.
Ouch, ouch disease.
Let's dive in and find out why.
Yeah, what's interesting about cadmium is that its story is kind of woven into so many different areas: art, technology, health,
Right.
and even the environment.
It's like this hidden thread connecting all these different aspects of our world. Okay, so first things first, where can we find cadmium on the periodic table?
Well, cadmium sits right below zinc in group 12, which gives us some clues about its behavior. Elements in the same group often share similar characteristics. And in this case, it means they both typically have an oxidation state of +2.
Oh, so they're like chemical siblings with similar tendencies.
Exactly. But
Yeah.
what's really unique about cadmium is that it can also exist in a +1 state.
Oh.
This ability to exist in different states is part of what makes it so versatile. It's like a chemical chameleon. It can adapt to different situations, allowing it to be used in a wider range of applications.
Oh, that explains why it pops up in so many different places. I was reading on the Royal Society of Chemistry's website that it's also incredibly resistant to corrosion, unlike a lot of other metals.
Yeah, that's right. That resistance to corrosion was a key factor in its early applications. I mean, think about it. A metal that doesn't rust easily.
Yeah.
It's a pretty valuable asset.
Yeah, especially back then. It makes you wonder how something that was once considered so useful, even in medicine, turned out to be so harmful. Speaking of history, did you know that cadmium was actually discovered by accident?
Yeah, it was 1817. And a chemist named Friedrich Strollmayer was working with zinc carbonate when he noticed something strange. Imagine his surprise when some of his samples, which should have produced pure white zinc oxide, turned yellow when heated. That's how he stumbled upon cadmium.
What a moment of discovery. It really makes you wonder if he had any inkling of the impact this new element would have. So how did it get its name?
Well, the name cadmium is actually derived from cadmia, the Latin word for calamine. You know, that pink lotion people use for soothing skin irritations?
Yeah.
Calamine is a zinc ore, and that's where cadmium was first found lurking as an impurity. So the name is a nod to its origin story.
That's a cool connection. But cadmium's story goes far beyond the lab. It actually had a rather glamorous debut in the art world.
Ah, yes, the cadmium pigments. Those bright, lasting colors, especially the iconic cadmium yellow, were a favorite among artists. Imagine Van Gogh's sunflowers without that vibrant yellow. It just wouldn't be the same.
It's fascinating how cadmium went from a lab curiosity to an essential part of an artist's palette. But that brings us to the darker side of its story. Remember that ouch disease we mentioned earlier?
Yeah, despite its vibrant beauty, cadmium has a toxic side. And ouch disease, also known as itai disease, is a stark reminder of that.
It's amazing to think that something so beautiful could also be so harmful. What exactly causes this disease?
It's a result of long-term exposure to high levels of cadmium. Often through contaminated food and water, the cadmium builds up in the body, especially in the kidneys, and over time, it wreaks havoc on the skeletal system.
Oh, wow. So how does it get into our food and water in the first place?
That's where the story of cadmium gets even more complex. We'll delve into the sources of cadmium pollution and its environmental impact after a short break.
All right, I'm ready to be surprised. Because from what we've learned so far, it sounds like this element has quite a range. From art studios to something called ouch disease. I can't wait to hear what else it gets up to.
Welcome back to our deep dive into the world of cadmium.
So far, we've learned about cadmium's colorful history, its accidental discovery, and even its surprising role in the art world.
But, as we hinted at before, this seemingly simple element has a complex side.
Okay, I'm all ears. What are some of these modern-day applications of cadmium that you mentioned?
You might be surprised to learn that one of the biggest uses of cadmium is in batteries, specifically the rechargeable nickel-cadmium batteries.
Wait, really? Those are still around?
Well, they are being phased out due to the toxicity concerns we've been discussing. But for a long time, they were the go-to for rechargeable batteries. And it highlights an important point. When it comes to technology, we often have to balance functionality with safety and environmental impact.
Yeah, it really makes you wonder what those early inventors would think if they knew about the long-term effects of cadmium. So if those batteries are being phased out, Where else is cadmium being used today?
Well, it might surprise you to learn that cadmium is used in nuclear reactors.
Hold on, nuclear reactors. That sounds a little intimidating.
It does have a bit of a sci-fi ring to it, doesn't it?
Yeah.
But it plays a crucial role in controlling the fission process, which is essentially how nuclear power is generated. Cadmium rods are used to absorb neutrons and help regulate the chain reaction, preventing it from spiraling out of control.
Yeah, that's a pretty important job. So cadmium is essential for both energy storage and energy production. It seems like this element is full of surprises.
And the surprises keep coming. Remember those quantum dot TVs we mentioned earlier?
Oh yeah, those super high definition ones that everyone's raving about.
Those use cadmium too. The quantum dots that give those TVs such vibrant colors are actually tiny nanocrystals of cadmium selenide. It's a great example of how our understanding of chemistry at a nanoscale is leading to incredible technological advancements.
It's amazing how something that was once a simple pigment is now being used to create cutting-edge technology. But with all these diverse applications, it makes you wonder about the potential impact on the environment. We know it's toxic, and we're using it in so many different ways. Should we be worried?
That's a very valid concern. Cadmium pollution is a serious issue, and a lot of it stems from those industrial activities we talked about earlier, like mining and the burning of fossil fuels.
I was reading in one of our sources that even the use of phosphate fertilizers can contribute to cadmium contamination in soil and water.
That's right. And once cadmium gets into the environment, it doesn't just disappear. It can persist for a long time, accumulating in soil and water, and eventually making its way into the food chain. Remember that study we mentioned about rice samples in China?
Right, the one where a significant portion of the samples had excess cadmium levels. That's pretty unsettling.
It really highlights the interconnectedness of everything. What we put into the environment ultimately comes back to us one way or another.
So what can we do about it? Are there ways to clean up cadmium contamination, or are we stuck with it?
That's where science and innovation come into play. Scientists are actively working on developing methods to remediate cadmium-contaminated soil and water. One promising approach is called phytoremediation.
Phytor what now?
It's actually a pretty simple concept. It involves using plants to absorb and accumulate cadmium from the soil. It's like using nature's own filtration system to clean up the mess we've made.
That's a pretty ingenious solution. So instead of digging up tons of contaminated soil, we can just plant some special plants and let them do the work.
It's not a perfect solution, but it's a step in the right direction. It's a great example of how we can use our understanding of science to develop sustainable solutions to environmental problems. And it underscores the importance of investing in research and development.
This deep dive has been a real eye-opener. It's fascinating how cadmium, this element with a rich history and diverse applications, also presents us with some significant challenges.
It really speaks to the complexity of our relationship with the natural world and the importance of responsible innovation.
Okay, so we've covered a lot of ground, from cadmium's origins to its role in nuclear reactors and quantum dot TVs, and even its impact on the environment.
But before we wrap up this deep dive, I want to touch on one more aspect of cadmium that might surprise you.
All right, lay it on me. What else have you got up your sleeve?
We've been talking about cadmium as a single entity, but it actually exists in a variety of forms. Cadmium compounds.
Oh, right. I remember learning about compounds in chemistry class, but I'm a little rusty on the details. Could you refresh my memory?
Of course. A cadmium compound is formed when cadmium chemically bonds with another element. For instance, you mentioned earlier how cadmium sulfide is used in photocopier drums.
Right. It was mentioned in that chemistry podcast we listened to.
Exactly. And remember those vibrant cadmium pigments used by artists? Those are actually cadmium compounds too. Cadmium sulfide for yellow, cadmium selenide for red, and so on. Each compound brings its own set of characteristics to the table.
So cadmium isn't just one thing. It's a whole family of substances with a range of properties and uses.
That's a great way to put it. It all comes down to the way cadmium interacts with other elements, forming these chemical bonds and creating entirely new compounds.
This is making me realize that there's so much more to learn about cadmium than I ever imagined. It's like opening a door to a whole new world of chemistry.
Exactly. And understanding these compounds is key to assessing the risks and benefits associated with cadmium. Because as we've seen, it's not just about the element itself, but also about the various forms it can take and the ways it interacts with the world around us.
Okay, so we've got cadmium, the element, and then we've got all these different cadmium compounds. But how do they actually get into the environment? I mean, I know we talked about industrial activities and fertilizers, but are there other sources we should be aware of? So we were just talking about all the different cadmium compounds out there. Before we took a little pause, It's kind of mind-boggling to think about how one element can form so many different substances.
It really is remarkable. It just speaks to the diversity of the chemical world. But as we were saying, understanding these compounds is really crucial because they don't always behave in the same way as elemental cadmium.
Right. So even though we've been focusing on cadmium in general, we need to keep in mind that its compounds can have their own unique properties and impacts, which brings us back to the question of how these compounds end up in the environment.
Well, as you mentioned earlier, industrial activities play a major role. Mining operations,
Mm.
metal processing plants, and the burning of fossil fuels. They all release cadmium compounds into the air, water, and soil.
And it's not just about what's being released directly, right? It's also about how these compounds move and transform once they're out in the environment.
Exactly. Cadmium compounds can travel through the air, dissolve in water, and bind to soil particles. They can even be taken up by plants and animals, eventually making their way into the food chain.
So even if we manage to control emissions from industrial sources, there's still the issue of cadmium compounds that are already out there in the environment.
Unfortunately, that's true. Cadmium doesn't just disappear. It can persist in the environment for a very long time, cycling through different compartments and posing potential risks to ecosystems and human health.
It sounds like a pretty daunting challenge. What can we do to mitigate the risks associated with cadmium compounds in the environment?
Well, the first step is awareness. The more we understand about the sources, pathways, and impacts of cadmium compounds, the better equipped we are to develop effective solutions.
So knowledge is power, as they say.
Absolutely. And once we have that knowledge, we can start to implement strategies to minimize the release of cadmium compounds into the environment. This might involve stricter regulations on industrial emissions, promoting the use of cleaner technologies, and developing innovative methods for remediation.
It sounds like a multifaceted approach is needed. We need to tackle the problem from multiple angles.
Precisely. It's not a simple fix,
Right.
but it's a challenge we must address if we want to protect the health of our planet and future generations.
So where do we go from here? What can we as individuals do to contribute to the solution? It feels a bit overwhelming.
It's understandable to feel that way, but even small actions can make a difference. Staying informed about the issue, supporting companies that prioritize environmental responsibility, and advocating for policies that promote sustainable practices. Those are all ways we can contribute.
It's empowering to know that we're not powerless in this situation. We can make choices that align with our values and support a healthier future.
And that's what I find so inspiring about science. It gives us the tools to understand the challenges we face and to develop solutions that can lead to a more sustainable and equitable world.
Well, I have to say this deep dive has been a real journey. We've learned so much about cadmium, from its fascinating history to its complex and sometimes troubling role in our modern world. It's definitely given me a lot to think about.
Me too. It's a reminder that even seemingly simple elements can have far-reaching impacts, and that understanding the intricacies of chemistry is essential for navigating the challenges of the 21st century.
Well said. I want to thank you for joining me on this deep dive into the world of cadmium. It's been an enlightening experience.
The pleasure was all mine. And to our listeners, thank you for tuning in. We hope this deep dive has sparked your curiosity and inspired you to learn more about the world around you.
Remember, there's always more to discover. Keep asking questions, keep exploring, and keep diving deep.